This is the final chapter in Gardner's book that we're going to be taking a look at in this course, and that's going to be Chapter 13, Special Scene Considerations. However, you're going to be held responsible only for the arson segment of this particular book, of this particular chapter. You are not going to be held responsible for the grave or the landfill excavation sections of this particular chapter. However, when you graduate and become employed, you may want to review those chapters should you ever sit for the Certified Crime Scene Investigator test. For our purposes, our learning objective for this chapter is going to be number 1, explain the meaning of cause and origin as it relates to the fire investigation. We're also going to be able to identify the basic types of fire patterns and explain how fire scene methodology will differ from normal crime scene processing. Before we do any of that, we need to take a look at our legal responsibilities. And I say not as right, but as responsibility. Now, under the Florida Administrative Code, Section 4A-61.001, local fire services must conduct an initial investigation. In other words, they can't simply dump off responsibility of fire investigations to the fire marshal's office. As a result of this administrative rule, law enforcement may choose to assist the local fire service. And this is where you may be called in to assist a fire investigator or assist a local fire department in performing a preliminary investigation. Therefore, it's going to be necessary for you to understand certain parts of fire investigation. Now, under the same Florida administrative rule, all this must be done before the fire marshal is called. So again, if law enforcement has an agreement with the local fire service, they may be called in to assist. And since crime scene is going to be the most prepared for such an investigation, you also may be called to assist. Now, fire scenes differ from other types of investigations because they're difficult, they're complex, and there's a lot of reasons why. Number 1, you're working in a structure that isn't stable. Why? Because it just burned. All of your framing members, your load-bearing walls, and so forth are going to be weakened. So you're going to have to wear either specialized clothing to protect yourself, or you may not be allowed in there at all. It's always a good idea to check with the fire command before you enter such a structure. There also may be a lot of debris. Again, keep in mind that the supporting members of the structure have burned, and it's not unplausible to have floors cave in and the contents of the upper floor end up in the lower floor. Lastly, fire services tend to be black and they don't reflect light very well at all. So if you're photographing and your meter is telling you one thing, you may want to consider opening up your aperture 2 or more stops, because you may be getting an artificial reading. And lastly, the fire scene investigation is a very specific objective, and that's to determine origin and cause. And this is entirely compatible with the Florida Administrative Code. If the cause and origin is determined to be a suspicious nature, then you may call in the fire marshal. Otherwise, the fire department is not legally authorized to request the services of the fire marshal. As we mentioned earlier, finding the origin and cause are the prime objectives in this fire scene investigation. Again, it goes part and parcel with the Florida Administrative Code. Now, when we're talking about seeking origins, that means we're looking for the specific location where the fire began. To seek the cause is to identify the reason why the fire started. Oftentimes it's not possible, so you may have to eliminate other possibilities until you get to a plausible conclusion. And if that plausible conclusion happens to be suspicious or incendiary, in other words, somebody started the fire, then you can call in for the resources of the fire marshal. Investigators will determine the origin and cause of a fire by examining the signs that the fire produces as it's burning. Now, even though fire is a dynamic and largely an event that's hard to predict, there are certain predictable behaviors. For example, fires tend to burn up, and we'll talk about that in just a moment. Some of these fire patterns that we need to take a look at are things such as char patterns, smoke and soot patterns, and damage patterns. These char patterns, smoke patterns, and damage patterns, they are usually visible and they're very measurable. So by a proper interpretation, we can determine the cause and origin. Let's look at char patterns first. A char pattern usually results from direct flame involvement. In other words, something had to be burning directly to cause a char pattern. And these could involve deep char padding of floor joists and wall studs, or some more subtle charring from the convection of heat on exterior surfaces. Since items will burn at a measurable rate, char pattern and char depth will help demonstrate how long something was burning compared to somewhere else. And that will become important as we'll see in just a moment. A smoke or a soot pattern results from the outflow of fire products, normally smoke and particulates. And there may be a horizontal line over large areas, or small vertical plumes. And these will demonstrate how the fire developed and flowed over the span of the particular structure. Damage patterns can occur anywhere in the scene, and it may just involve one object, or several objects, or entire surfaces. Heat and flame will cause damage. Anything that's facing away from the heat and flame will generally receive less damage. And these will indicate how the fire flowed inside the scene. Basic method of fire scene investigation isn't that much different from any other crime scene. However, there's certain additional considerations you must observe. First off, assessment always begins on the outside. If it's possible, you'll want to take an elevated picture of or at least an elevated observation of the fire scene. And fire service equipment may help in that endeavor. You may be able to get onto a ladder truck or an elevated platform to get that elevated view. The elevated view helps shoot on and any outside viewers to understand the full extent of the fire. Now, when we conduct assessment and observation of the fire scene, we usually conduct that assessment from the least damaged to the most damaged area. And this allows you to have a context when you're observing, so it makes it easier to evaluate what surface may be more or less damaged. Oftentimes, heavier damaged surfaces may be indicative of the use of an accelerant. You should also examine all fire signs independently, which means you evaluate the burn patterns, the char patterns, and so forth in a step-by-step process. And this may require you to do a certain amount of excavation, which means getting out the tools and shoveling debris away. Always look for evidence of what Garner likes to call low burn. Now, fire naturally flows up and out, so any area in the scene exhibiting low burn is of interest. Low burn tends to indicate that the area in question may require additional investigation. If you have multiple points of low burn, that may or may not necessarily be arson. There may be other reasons why that occurs. However, it indicates that the area deserves additional investigation. So that would tend to mean that several areas of low burn may heighten your index of suspicion. Finally, what we're going to do is we're going to shift gears a little bit, and we're going to look at how crime scene investigators should be responding to reports of clandestine laboratory activity. This particular presentation was borrowed from Eric Hall at the University of Cincinnati, and as a condition of licensure, I'm obligated to recognize that this is Mr. Hall's work. If you remember from your syllabus, we have a performance objective that we must meet, and that is we have to demonstrate knowledge and ability to safely and properly collect, mark, preserve, and transport evidence from clandestine laboratories. So this particular instructional unit, while it does not appear in your textbook, will certainly be appearing as a test question in the final examination. Okay. Methamphetamine, also known as meth or any host of other names, is a DEA Schedule II controlled substance. That means it has limited medical use and a high potential for abuse. Currently, the FDA only recognizes methamphetamine as a potential treatment for ADHD and short-term weight loss. There's also some medication studies going on right now for narcolepsy. It is manufactured in clandestine labs and is probably the single most produced contraband item in a clandestine lab. So therefore, it's the one item that you will probably run into. Probably about 20 or 30 years ago, there used to be places you used to find the occasional laboratory that was producing other sorts of pharmaceuticals, such as heroin and cocaine and so forth, but those have been mostly supplanted by methamphetamine. Methamphetamine is also readily made using chemicals that are found in a grocery store, hardware store, Walmart, big box building store, and any one of a host of other places. Now, there's no formal chemistry training required to produce methamphetamine, and that's one of the reasons why it's so dangerous. Usually, people with less than a high school diploma are making methamphetamine using directions supplied by other more experienced cooks, and it's more along the lines of other lucky cooks that have managed to survive the process. So what is methamphetamine? It's a very powerful stimulant. In other words, it activates certain systems in the brain, and by so doing it activates the pleasure receptors in the brain due to the massive release of dopamine caused by the methamphetamine. So why is meth being produced? Number one, it's very easy to make, as we discussed before. A lot of folks can make it, and they don't have to be trained chemists. Number two, the ingredients are very easy to obtain. Number three, there's a huge profit margin. $600 worth of chemicals can produce over $2,000 worth of methamphetamine. So you're talking over 300% profit margin. Basically, there are two types of laboratories currently in operation in North America. Number one is the so-called super labs, and number two are commonly termed mom and pop labs. We'll talk about each of these in turn. Super lab is a highly organized lab that can manufacture at least 10 pounds of methamphetamine per production cycle. We haven't seen very many of these so-called super labs anywhere in Florida, but they tend to be concentrated more in the Mexican border areas, Southern California, Southern Arizona, Texas, and so forth. Usually in areas that have very little human population, and areas that usually border Mexico because that's where the raw material is coming from. In this country, methamphetamine raw materials are regulated, and if someone is obtaining those materials in quantities large enough to supply a super lab, they're going to generate a lot of attention from law enforcement. This is probably the more common laboratory that law enforcement is going to run into, and that is what is commonly termed the mom and pop lab. These are small scale labs, and they generally only produce about 1 to 4 ounces of methamphetamine per cycle. But still, it's quite a profitable venture at $500 to $2,700 street value. These people generally produce just enough drugs for themselves and others, and enough to sell so they can continue to buy chemicals and produce more methamphetamine. In a clandestine lab, methamphetamine is produced in one of 3 different ways. The one that's used the most often is the red phosphorus, or also known as the red pea method. And this is where ephedrine and pseudoephedrine are combined with red phosphorus and are then reduced to methamphetamine. The problem is that this sort of production method produces phosphine gas. Phosphine gas is lethal in relatively low concentrations, and not only could you inhale it, but it can also be absorbed through the skin and be just as lethal. Second method that's often used is called the Nazi method. Apparently this method was attributed to Nazi Germany during World War II when they were producing amphetamine for use by their troops. It's also known as the Birch method. And this method uses anhydrous ammonia. Anhydrous ammonia is a common fertilizer in rural areas, which is why so often farmers will find that their anhydrous ammonia tanks have been drained out. The other ingredients in this method are pseudoephedrine or decongestant pills, and lithium, which comes from lithium batteries. The reaction of which can create ammonia gas, which is also dangerous. In fact, ammonia gas was first used as a trench warfare agent in World War I. Finally, we have the P2P method, which stands for phenyl 2-propanone. This particular method is the method of choice used by motorcycle gangs. However, by the 1990s, ephedrine reduction using the so-called Nazi method became more popular. So this method is not used very often. Methamphetamine labs can be recognized by a number of different factors. One, there's frequent visitors to the location at all hours of the day and night. Activity at the home is usually also at night. The occupants have no visible means of income, yet they always have a lot of money. There's also extensive security at the home. You'll find they may have a lot of cameras, a lot of alarm systems, and a lot of people that are posted on the perimeters looking for somebody. And it wouldn't be just law enforcement. They are also looking for people that are looking to invade and steal either the drugs, the money, or both. Typically, the windows are blacked out, the curtains are drawn, and there's chemical odors coming from the house. And these odors may resemble ammonia or cat urine. If you happen to notice that smell coming from a home, that's usually a good sign that you probably shouldn't be going in. You should be calling for some backup. There will also be a significant amount of garbage in and around the home because it's trash that they can't put out by the curb, because that trash would indicate that there's a meth lab in operation. In these trash piles, you'll see that there'll be several bottles and containers. There'll be a number of coffee filters that are stained red, or they have a smell resembling ammonia. This would be an example of just such a meth lab. This particular lab was in a converted camper trailer located in the woods. As I mentioned before, their trash is usually dumped nearby because it can't. If the trash were to end up in the municipal trash stream, it would be readily detected by law enforcement. And this is another method of disposing of trash from a methamphetamine lab. Oftentimes they'll use burn pits in an attempt to destroy the containers on the spot. Notice, if you will, there's at least 3 cans of either acetone or camp fuel or something similar to that. And what they will try to do is they'll try to burn these to avoid recognition. This open trunk lid shows you that a meth lab can also appear in a vehicle. There are plenty of mobile meth labs that are around. Again, another example of a camper trailer being used as a meth laboratory. And these are some of the different things that are used as replacements for laboratory equipment. Typically, they'll attempt to reuse tempered glass, baking dishes, Pyrex ware, glassware, plastic jugs, jars, paper towels, coffee filters, funnels, and so forth. Rubber tubing, rubber gloves, buckets, blenders, all sorts of different household items that are being improvised as laboratory equipment. This graphic shows some of the different things that are used to produce methamphetamine in a clandestine lab. Notice that most of the stuff comes from grocery stores, Walmart, or other big box stores. And here's an example of methamphetamine that's just been cooked, washed, and dried. There's a white crystalline residue on the bottom of this pan, and this is methamphetamine that's recently been processed. and now it's awaiting being scraped up and packaged for sale. This is an example of a meth lab that's much better financed. Notice the actual purpose-built laboratory glassware that you see in the foreground. And this is an example of another well-financed meth lab. You have in the foreground you have a container of some kind of solvent. You have a laboratory hot plate with a mason jar of methamphetamine liquid precursor. Also, you have in the foreground over-the-counter pills such as mini thins and pseudoephedrine that's currently being prepared for production. This here is probably the most telltale sign of all. What you're seeing here in this particular photograph is a propane tank that was used to steal anhydrous ammonia from either a agricultural concern or from a refrigeration plant. Take a careful look at the gas hardware in this photograph. If you'll notice, that gas hardware is no longer a yellow-colored brass. It's actually turned blue, and this happens when brass is exposed to anhydrous ammonia. This condition not only turns it blue, but it also weakens the brass fittings, and every so often these particular containers will explode. And here's another example of a clandestine meth lab. There's a number of cans of starter fluid, which is commonly used to wash the methamphetamine. You have large quantities of salt, other assorted solvents, and the telltale propane tanks with the blue fittings on them. And here's some of the various household chemicals that are used to produce methamphetamine. Number one on this list is ephedrine and pseudoephedrine, and then there's all manner of household chemicals used as solvent washes for the methamphetamine mixture, such as alcohol, toluene, ether, sulfuric acid, and so forth. Anhydrous ammonia is another major component in methamphetamine production. Red phosphorus coming from match strike plates, iodine, sodium hydroxide, which is a drain opener, rock salt, trichloroethane, which is used to clean guns, and kitty litter, which is used to absorb chemical spills. And here's another example of a clandestine meth lab. Notice all the solvents that you see in the foreground here. All these, including the camp stove fuel, are used to produce methamphetamine, and they're all commonly available at your convenient hardware store. Now, let's look at some of the dangers that are associated with clandestine lab production. First and foremost is physical injury. Keep in mind these people that are mixing methamphetamine are not graduate chemists by any stretch of the imagination. So they're not particularly aware or appreciate the dangers that are involved in this sort of activity. These fires and explosions not only can affect the user themselves, but also the neighborhood or anybody else showing up, including law enforcement, fire, and crime scene personnel. What we have here is an example of a fire department responding to a clandestine lab, and this is what happens when improperly stored and mixed chemicals get together and they cause a fire and explosion. Aside from the obvious or the less obvious dangers, there's the more obvious dangers. Since methamphetamine users tend to be paranoid, they usually are armed and sometimes will use improvised explosive devices rather to protect their laboratories. Now, because laboratory response is so dangerous, meth lab investigation is regulated by OSHA, which means OSHA has some very, very clear rules as to who's going to respond to these laboratories. A OSHA compliant investigation class is not offered all that often and usually offered to a very limited audience. The nearest training provider in this part of Florida is going to be in St. Petersburg. These classes are limited only to sworn police officers and military personnel. And that's for the people going inside the lab. Support personnel, people that are outside the lab, have to attend at least a 24-hour class. It's also restricted to sworn police and military personnel. As mentioned before, persons trained at this level do not enter laboratories or handle any material found inside. Finally, there's an 8-hour laboratory recognition class. And these people are trained to recognize certain hazards. They also do not enter laboratories or handle any material found inside the lab. So, how does this impact your operation? Bottom line is, clandestine lab response teams are expensive and usually in short supply. Many areas, including this area, have regional laboratory teams that are organized under the Florida Department of Law Enforcement, and they are usually comprised of specialists from a number of different agencies. Typically, crime scene investigators do not participate with these teams. So generally speaking, should a civilian crime scene investigator find himself in an area that has indicators of clandestine lab activity, they should not touch anything, not collect anything, and leave immediately. The only people that should be occupying that space and collecting evidence is a clandestine laboratory team that's specially trained and equipped for such operations. And the reason is simple. If you pick up anything, you may end up triggering a booby trap, or worse, you may end up disrupting a chemical reaction that may run away and become a catastrophic explosion or fire. So, the best thing a civilian crime scene investigator can do in a situation like this is recognize it for what it is, leave, and call in resources. This is going to conclude our presentation series for this course. If you have any questions, feel free to contact the instructor either through Blackboard or the instructor's email or text messaging system listed on the syllabus.